Hello everybody, hope this finds you well. We're going to talk about solving some nonlinear inequalities. Okay, the two types that we're going to talk about, one is quadratic, another one is rational, and those are quite different types of functions. However, they share some pretty common characteristics when it comes to the process of solving the inequalities. The basic process for both of them is about the same. So that process, to kind of lay it out for you here, the first thing is that both of them you should set to 0. If it's not already given to you set to 0, then you should do the work to set it to 0. That's very important. Next step would be to find all the solutions as if it was an equation. Now that's a little bit tricky terminology there because it's not really the solutions to the inequality, but I'm sort of pretending that that inequality is set equal to 0 and I'm solving it to find those 0 numbers. Sometimes we call them the critical values or the 0 numbers, something like that. But anyway, I want to find those numbers, and then when I find them, what I need to do is I need to put those, I'm calling them solutions again, I hope that's okay, on a number line, and then I test values in between them to find the actual solution interval for the inequality. Sometimes there's more than one interval. Sometimes it's a union of two intervals, possibly even more, but our examples here won't go more than 2. So let's take a look first at a quadratic example, and for our viewing pleasure, I've chosen this one, x squared minus 4x greater than or equal to 12. It's not set to 0. So the first thing is to set it to 0. That was pretty easy. And as you can see, that's a pretty standard looking quadratic expression there on the left side. It factors real nicely to x minus 6 times x plus 2, and therefore our critical numbers are 6 and negative 2. Okay, so what we're going to do is take 6 and negative 2. The next step there, as you may recall, is to put those numbers on a number line. I take negative 2 and 6, and I'm going to test values in between. So first, I'll test some numbers less than negative 2, such as negative 3. And it's an interesting fact that whatever is true for negative 3 is true for every number less than negative 2. So I'm just picking negative 3 because it's easy. I put negative 3 into the inequality. Negative 3 minus 6 times negative 3 plus 2 greater than or equal to 0. And I work that out, and I get negative 9 times negative 1. Yeah, that's positive, groovy, okay? It's positive 9. 9 is greater than or equal to 0, so that's good. So let's try a number between negative 2 and 6, which, like 0, I like to use 0 just because it's really easy. When you put 0 in for x, we get this weird thing that says negative 12 is greater than or equal to 0, which I hope you realize is not true. And therefore, that interval there is not part of the solution. When we take a number greater than 6 in the final interval there, greater than 6, and work it all out, we get also a positive number. So there's our number line test results. The two intervals that are positive are less than negative 2 and greater than 6. We've got a greater than or equal to sign in the inequality there. So that means I can actually include those values in the inequality. So it's negative 2 and below, and positive 6 and above. So our actual solution turns out to look like this. It's a union of those two intervals there, negative infinity to negative 2 and 6 to infinity. That's the solution interval. That's how we write it, with interval notation. Okay, let's try a rational example, such as x plus 4 over x plus 1 is greater than or equal to 2. Once again, it's not set to 0, so we have to do that. That's pretty easy, though, also. Just subtract 2 from both sides. But I've got this situation here where I've got a fraction minus a whole number, and I can't really simplify that left side there until I change the 2 into a fraction with x plus 1 on the denominator. So I need a common denominator before I can combine those two things. And that's not too bad to do, really, in this case. I just multiply by x plus 1 over x plus 1, and I combine my numerators like that, and simplify everything, and that's what I wind up with. That's a little different there. I've got 2 minus x. Make sure that you understand why it's 2 minus x on top, and x plus 1, of course, in the denominator. Now, so let's take a look at this situation here. 2 minus x over x plus 1 greater than or equal to 0. I am going to put some numbers on a number line and test the values in between those numbers. But let's think about this for a second. The same principle holds true for division as for multiplication, namely a quotient, that is, of two positive numbers is positive. A quotient of two negative numbers is also positive. So to find the solution interval for this inequality, I need the top and the bottom to be either both positive or both negative. Okay? So the expression 2 minus x, for example, changes from positive to negative when x equals 2, right? 2 minus 2 is 0. So a number greater than 2 would give me a negative numerator, and a number less than 2 would give me a positive numerator. That's a little confusing sounding maybe, but I think you'll think about it for a second, you'll see that that makes sense. So what I'm going to do then is choose 2 as one of my critical values. And very easily I can come up with the critical value for the denominator of the fraction, -1. That's what makes the denominator equal 0. And so you can see I'm really looking for the zeros of the top and the bottom. Okay, the numbers that make the top and the bottom equal 0. Those are my critical numbers. And I will now test values in between those to figure out the sign of my quotient. Okay, so first let's take a number less than -1, put it in the top. That gives me a positive value. If I take a number less than -1, put it in the bottom, that gives me a negative value. Okay, just think for a second. I know I'm speaking very quickly, but let's say 2 minus -2 on the top is positive, and -2 plus 1 on the bottom is negative. So I got positive or negative, and that gives me a negative quotient. If I take a value in between -1 and 0, put it in there in the top, I get 2 minus, let's say, 0. That's in between. 2 minus 0 is positive, and 0 plus 1 is positive, so positive divided by positive is positive. So that's good. That's that interval gives me a positive quotient. Let's just try to the right of 2. 2 minus 2 is negative, and 2 minus a number greater than 2, like 3. 2 minus 3 is negative, and 3 plus 1 is positive. Therefore, I got negative divided by positive. No good. That's negative. And so we've seemed to have found our solution interval there, right? Remember, we're looking for values that make this quotient positive. So right there between -1 and +2 gives me a positive quotient. That's great. Now, we've got a greater than or equal to sign, so you might think that we should use brackets in our solution. However, we can't do that. I have to use parentheses around -1. I can use a bracket around +2, but I can't around -1. I'm going to give you a second to think about why we have to use parentheses around -1. Okay, there was a second. Did you figure it out? Yes, hopefully you did. You realize that if I make x equal to -1, I've got 0 on the bottom of that fraction. So x cannot equal -1. Can't divide by 0. So I have to use parentheses in my solution then. And there's the solution interval, parentheses, -1, comma 2, with a bracket on around the 2. And we're done. Now go do some math.